Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture video in the series, Statistical Data Representation, in this video we are going to see a design thinking based approach to cumulative frequency distribution. So here is the recall. So before introducing cumulative frequency distribution, let's quickly recall what we know already. So frequency distribution helps us organize the raw data into a meaningful groups. So in that we are having four types: ungrouped, grouped, cumulative and relative frequency distributions. So today let us focus on, in this video let us focus on what is our cumulative frequency distribution and understanding how it supports decision making. So these are the learning objectives of this video. So by the end of this lecture video, we will be understanding what is or how to construct a cumulative frequency table, calculating cumulative frequency accurately, interpreting cumulative frequency data, draw meaningful conclusion using a cumulative frequency. So understanding the application of cumulative frequency curves like ogives and all. So the next one will be the design thinking based approach. So in that, now let us begin our thing. So imagine a placement coordinator after conducting an aptitude test for 300 students. So principal is asking how many students scored below 70. So normal frequency table cannot answer this immediately because it only shows the number of students in each class. So we can actually need in the role of calculating. So in that cases and all, we can use this um, cumulative frequency distribution to find the or to interpret the data more efficiently. So one of the quickest way to calculate the percentages are this frequency tables. So next is in defined part, in which how we can determine the number of observations below or above a specific value quickly. So to solve this problem, we first create a frequency table, then we calculate cumulative frequencies by adding frequencies successfully. So then this transforms raw numerical data into a useful information for decision making. So first is we have to collect the raw data, determining the range, class intervals. Next we have to calculate the total frequency and construct the table. So next is in understanding cumulative frequency distribution. So for example, if we are having a students like in this count given in the frequency table, like 10 to 20 there are 5, 20 to 30 there are 12, 30 to 40 18, 40 to 50 15, 50 to 60 is 10, and the total is 60. So for how to calculate a table is, first we have to identify the interval. So the interval gap is 10. Next we have to classify the boundaries. Next we have to calculate the midpoint. So midpoint is nothing but the total values, and we will calculate. So if we want to calculate the cumulative data, first we have to add this 3, then 12, then 12, the sum plus 18, like that we have to add. So which will give the final one. So next this is in ideate part. So in ideate part we'll be seeing the start with frequency table. Next we will do add progressively, like first value plus second value, next sum of the first and second value plus third value. So similarly we'll go to the final value, that is the formula. Next is a prototype part, in which suppose there are 50 students are collected. So the first minimum and maximum value is what we are going to find. So for this, first we have to calculate the range. So calculate the range by classifying it in a class interval. Like we have to make the raw data into a grouped data first. So in terms of intervals, 20 to 30 till 80 to 90. So the minimum value is found to be 23 and the maximum value is found to be 90, and the range will be 67. Range in the sense the mid value, like that. So next the class intervals width will be 7 classes totally. So it is 10. So next we have created a classes. Next tally frequencies will be F. Next calculate cumulative frequencies. The last will be the cumulative frequencies. So here we can see there are few problems so which can be given as a class. So here is a testing part in which cumulative frequency tells us the number of observations that fall below the upper boundary of each class. This allows us to answer the questions like um, for example, in the starting we have seen in the placement officers question. So how many scored below 70? So from this table we can identify and tell how many students have been securing below 70 or above 80 like that and all. So here is the visualizing cumulative one. So in which OGA was obtained by plotting cumulative frequencies against the upper boundary classes. So here is one of the practical application in which how we can identify the number of or how we can spend. So this is short mind map on cumulative frequency distribution. Thank you.